my name is Tobilaba.
And my name is Drachi. Welcome to the Manka, where we discuss architecture and life.
Today we'll be talking about breakthrough in design technology.
Okay. Well, I think new technology is really important, especially for Nigeria, because we need to be able to solve the new problems coming up without repeating things our industrial predecessors have done, especially areas with pollution and housing and all those things. And we feel these technologies that we want to look at today are things that will greatly improve what we already have or help us be able to afford newer technologies that are available. I'll start with a favorite of mine, which is mushroom materials by Ecovative. Basically, what they do is they grow this mycelium fungus, and after it grows to a certain point, before it begins to spore and everything, they mix it with agricultural waste like corn husks and chaff. Yes, exactly. And when they mix it up, put it thoroughly mixed up, they put it in molds. Now, Ecovative, their main line, I won't say their main line, but the more popular arm of their business is packaging. And so they put them in molds for those kind of packages and leave them for a few days to grow. So after those few days, they take them out, put them in an oven, both to dry up the material and to kill the bacteria. So the growing process stops, so it doesn't just keep going and going and going out of form. So I feel it's something that it's a really good idea because it's 100% recyclable. Yeah, biodegradable. You can literally just toss it out and not be worried about how the ecosystem will deal with it.
Yes, because it will decompose and you can even use it as a composting material.
Yeah.
So, but how does it work with designing buildings?
Well, for designing buildings, I know it's been used. Ecovative as a company has tested their technology as insulation in buildings for like temperature regions and everything that needs a lot of insulation. But there's another example I found. The Museum of Modern Art. They have this exhibitions they do every few years or every year, I can't remember. And they invite designers. I think this year or so, I'm not sure if it was this year or last year. There's this beautiful exhibition space or pavilion space rather, that is made of blocks of this mushroom material. It's not Ecovative's particular system, but it's the same principle of the fungus and the agricultural materials mixed together to form like a block. Everything. So these blocks were stacked on each other just to create like a space where people can come, sit down, chill, move around, that kind of thing. Topped with reflective bricks. It's really nice, really beautiful to see. So I think there is potential to it.
So I guess it depends on the strength of the strain of the fungi.
Yes, that's actually like the main technology behind it. I think the stronger they want the material to be, they have to treat it with like different strains of fungus so that they get the particular mix or the particular strength that they're trying to achieve.
Yeah, that's really, really good. And well, I hope it's less expensive also.
Hopefully, they claim it is. I think the big sell is on its complete. I don't see how it can even be more expensive because really it's agricultural waste and mushrooms. So
what I'm wondering about the cost is the particular strain of the mushroom.
Yeah, but you see that's why they have a team of engineers and biologists and people who study these things and work with them. Yeah. So
because you can't just get mushroom that grows from anywhere.
No, it's not just any random mushroom. It's a particular mycelium fungus, yes. But I assume that when you grow them in large quantities like that, at a certain point it becomes like cheaper in a sense when you have them like in volume and everything. I assume that it will be cheaper. It would be nice if it was something we could do here, even not necessarily with that fungus, but to take the.
You can even test it with any kind of mushroom that we have over here,
because really it's the same principle of this adobe bricks that they mixed with straw.
Okay, that makes it
yeah, so it's like a combination factor. Only that in this case the adobe is the mushroom, the straw is straw. So
yes, it's something that we are looking at. right?
Yes, 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 yes.
Yeah, it's something we're looking at to maybe possibly research into
Yeah,
sometime
it should be really
soon.
Yeah. So you were going to tell me about
Self-healing
concrete.
Yeah. Okay, we all use concrete in Nigeria. Everybody uses concrete everywhere, and the major problem that we all have with concrete is the cracking. Even the modernist era, Le Corbusier started with concrete, and that was everybody's major issue, cracking of concrete. So there's this new technology in Netherlands. Some engineering team came up with a new technology. They mix the concrete with bacterial pores.
Okay.
So they mix the concrete with it, and it heals. It's called self-healing concrete. So the concrete heals on its own if you mix it with water or sunlight. There are two different.
Okay. So so what you're saying is like when it cracks.
Yes. So when it cracks, and you can add water to the cracks.
Okay. So
section.
like if it rains, that kind of thing.
So any water, whatever kind of water, like once it rains, it spurs it into action.
Okay.
It spurs the bacteria into action, and it heals the concrete from
that's
inside.
Nice. That's really nice. Because at least that way you don't have an issue. Like I know in temperate regions you have the issue where water gets into the cracks and then freezes and expands and freezes and expands and it just
then it even keeps
expanding.
breaking up,
Yeah.
and keeps cracking. But this time it actually aids.
Oh,
That's a very cool, very cool thing. But it's just that right now though we don't know the kind of bacteria that use, but
it seems to be like an experimental.
it's very experimental for now. They're hoping maybe in a couple of years they'll bring it out into public to.
Something about light and water.
Okay, yeah. So the water one works with the bacteria.
Okay.
But the sunlight one is a kind of polymer. It's partially organic. So whenever there's sun,
But I think that was really good, especially for us here, where construction practices can be
a little
iffy.
Yes.
I mean, concrete will always have those cracks, regardless of what you do. You have to be really precise to get concrete built without any cracks. There will always be those small hairline fractures, or it's
for you to have cracks in this concrete buildings too. It's not a thing. It's not particularly about the construction workers or the practice. So it's just about the
bacteria itself. Defect that concrete has. Yeah.
So we hope this technology will be out very soon and it will be perfected at least.
I agree. It's something that would do so well, not just in Nigeria, but like worldwide and everything. Imagine, because you're increasing the lifespan of concrete more or less.
Yes, definitely, because it will still, it will live longer.
Yeah.
Than having to try to patch up everything.
That's really cool.
And there's also the
dyes, the solar cells.
Yes.
Okay. This one I found because we're researching solar cells, I think one of these days, and something I came across called dye sensitized solar cell. Basically, it's some sort of crystal that mimics photosynthesis. It's like the whole trapping light and transparent energy that you were talking about biology and everything. Yes, but the thing that is so cool about this is that it's a crystal and it's embedded in titanium dioxide. Sure. Yes, titanium dioxide, which is apparently that stuff they use on grass tennis courts to draw the lines. I always wondered about it, but apparently you can embed it into that kind of surface and like apply. So it comes out like a very light, very flexible surface that is a solar cell.
Okay, so are you trying to say that if you apply that material in the voltage, it can actually absorb?
Well, yes, it's just there's no, not just the titanium dioxide. It's the crystal.
The crystal.
Yeah.
So you can just mix it with it and then just
apply it on whatever
surface and it just absorbs the
sunlight. I think the trick is to be able to now adapt it to transfer the energy somewhere.
Okay.
Yeah. But it's really nice, and from all the reports I've read, the technology is a lot cheaper to make than the standard solar cells that we have now. And it's a lot lighter, it's a lot flexible. So there's a wider range of things you can do with it. Not just flat, rectangular or square shaped panels. You might possibly be able to have curved panels and everything. The potentials are pretty amazing, but I haven't really heard any final word on it yet.
Yeah, if it's actually used for like commercial purposes.
I know the report I read was planning to commercialize in a couple of years after that report came out in, I think that was last year in July or so. So hopefully something that will come out quickly so that we can enjoy the benefits. Because the main issue, well, not the main issue, but people that argue against solar technology, especially here in Nigeria, they say, oh, it's so expensive, it's a third world country, how do you sell it to how do you sell it to Nigerians and everything? I think this would be something that it would be really good because it will help. Okay, now it's cheaper and it's more flexible. Why are you still using your generators? Yeah, so I think that's really good. So that's that. We were talking. We were
going to talk about sweating.
Sweating overseas.
Yes, that's
exciting to hear.
Sweating. Okay, basically the way it works is it mimics the way when you sweat, you give out water.
Okay. Cool your body down.
Cools your body down. That is exactly the way the system works. So there's a team in Zurich, a group of an institute of biochemical engineering or something like that. So what they did was they developed a mat to cover your roof.
Mat, like
yes,
the regular mat.
Yes,
Okay.
it's made of a special polymer. It has the initials of PNI PAM.
PNI.
Yes, that's the abbreviation of the polymer. Yes, so basically what the mat does is when it rains, it absorbs the water. So the special polymer is like the mat.
Okay,
I don't know how
they
to-
mop like that once.
Yes, so it absorbs the water.
It just
Mhm.
absorbs water and expands.
And expands.
Holds it.
Yes, and holds the water in.
Okay.
So what the cooling system is the special polymer underneath it, but the water absorbing agent is a different membrane
Okay.
on top of the
The
special polymer. Yes.
Okay.
So basically what it does is when it now starts getting hot,
Okay.
it now releases.
Oh, that's
water.
really
So-
cool.
Well, I'm not sure exactly how it will look like, but the idea, the way you're supposed to picture it is the water will be dropping down the building.
Literally sweating down.
Yes, that's why it's called sweating.
Oh, that's really cool.
Yeah.
Yeah.
So it's
Reduces, I think, like
Yes.
the amount of cooling.
yes. Well, they tested it. They've done a couple of tests with smaller buildings, not big buildings, but some smaller buildings, and the test revealed that it actually reduces usage of AC
Oh,
by 60%.
60.
That's a lot.
Wow, that's a lot.
That's a whole lot.
That's a
60%.
lot.
Imagine, but anyway, they tested it in a colder temperate region.
Yeah, but still 60% is pretty
yes.
impressive.
So maybe we'll just be looking at, because it's always hot here in Nigeria.
Mhm.
So maybe we'll just be looking at maybe like 40 thereabouts.
Yeah.
So
Okay.
that's even still a
Oh,
lot
that's really
for,
cool. Yeah.
for the hotter climate.
Mm-hmm.
So yeah, like it's just the exact same system. So there's nothing changing about like yes. So you just sweating, and then the water now drops down the building and cools the building down. And I'm not sure if it's exactly a drawback or something. It says when the research was like when it gets hotter than about 32 degrees, the membrane now turns to like a hydrophobic,
Oh, so it just repels water.
something like that.
Ouch. Okay, but well, it's not really a drawback.
Yeah, that's
Except if
something
it's
that-
really hot and it's raining. Then.
yeah.
Okay,
Well,
but that's nice because that means for it to work, it doesn't need power. Not that it doesn't really need power.
Yeah,
It doesn't need any external power source.
No. It's just
Once it
top of
heats
the-
up, it just throws the water out. Oh, that's nice.
Yes, and well, they claim it's inexpensive, but
Expensive is relative.
very, very, very expensive. Because we're going to try to look at the Nigerian content, because no matter what is inexpensive anyway, as long as you're trying to bring it into Nigeria, it's definitely going to make
Well, it's something we should definitely consider. If we can develop a system like that here, or find a way to subsidize the costs, bringing it in at least for the first few runs before we develop our own system. I think it's something that will really do well. I think all the technologies we've mentioned today, and there's so many more. I think we'll add links.
Yes, we'll add links, and apart from that, so there are still some technologies in Nigeria that some professors are working on, like the concrete where you don't need to use. Oh, sorry, I said concrete. The cement blocks where you don't need to use mortar.
Okay. To stack
them together. They actually maybe work like some of them do joint system.
Yeah. So instead of using the standard block mold, you have those really good.
Yes. So you just
stack them
and just fix it in.
That's really cool.
Yeah. So if we have a proper reference for that, we'll definitely put it in the reference section too. And we'll probably expand more on it at some point later on.
Yeah.
And so follow us on Twitter at d.manka.
And don't forget to subscribe. Thank you so much for watching. Bye.